halogenation and reaction with nitrous acid. Let's start with the first, that is halogenation. We would first talk about primary nitroalkane. So let's take one primary nitroalkane. Now, to this we are adding a bromine solution, that is we are adding 2Br2. And to this we are also adding 2NaOH. So now what would happen, let's see. But before going on with the reaction, we can do one thing. Bromine can be written down something like this. NaOH can be written down something like this. So now what happens is you have two alpha hydrogens, if you remember, into your primary nitroalkane. Let's see what happens. Primary hydrogens or the alpha hydrogens combine with the OH group, giving us water. And now we would obtain one molecule of water, but there are two alpha hydrogens. So obviously second hydrogen would again combine with the OH of NaOH, giving us one more water molecule. That means total of two water molecules. Now what would happen? Na is there. It would combine with Br, giving us NaBr. So one Na is lost. Now we are still remaining with one more Na, right? And again this would also combine with bromine, giving us the second molecule of NaBr. That means again we have two NaBr, right students? Now what we are remaining is, we are remaining with RCNO2, carbon with two unsatisfied valencies, and both of these would be satisfied by bromine. So now you can say that yes, we have obtained a product that is nothing but a dibromo derivative of a primary nitroalkane. So this is how your primary nitroalkane would go for halogenation. Let's now talk about the secondary nitroalkane. Let's take a secondary nitroalkane, react it with bromine in the presence of NaOH. Now what would happen? Again, acidic hydrogen combines with OH, that is your alpha hydrogens, giving us a molecule of water. Na combines with Br, giving us NaBr. And finally, the secondary nitroalkane is converted into a monobromo derivative of secondary nitroalkane. Let's talk about tertiary nitroalkane. Let's take a tertiary nitroalkane, but now tertiary nitroalkane does not consist of any alpha hydrogens, so they would not react with halogens. An important note over here is, if you react nitromethane with chlorine, you would get a compound that is a trichloro derivative called as trichloronitromethane, also referred as chloropicrin. And remember my students, it is a very effective insecticide. So this was all about the halogenation reactions. Let's move further and now discuss about the nitrous acid reaction. So let's take a molecule that is a primary nitroalkane, react it with nitrous acid, but nitrous acid has to be prepared in situ using NaNO2 and HCl. So what you would get? You would get HNO2, which can be written down as OH N double bond O. Now what happens over here? Let's see. H and OH, that is again the alpha hydrogen, combines with OH, giving us water. So what we are remaining is with nothing but RCHNO2. To this, N double bond O gets attached, giving us a nitro form. Remember student, this is a blue color solution. Now what happens? As it consists of an alpha hydrogen, it undergoes a process called as tautomerism, and because of this, what would happen? Let's see. Then the bond of carbon hydrogen gets shifted towards carbon nitrogen, and N double bond O gets converted into N single bond OH. Let's see the reaction. So you get a compound something like this, that is RC N double bond O. See, the same carbon is attached to double bond NOH and oxygen with a negative charge. Now again, this solution is called as an acid form, and it is also blue in color. If this solution is reacted with NaOH, let's see what happens. It was an acid form, it would combine with an base, H would be removed, you would get a water molecule. So now what you are remaining is with nothing but a group consisting of ONA. And remember student, this is a red solution. Let's talk about secondary now. Secondary nitroalkane now reacted with HNO2. What you would get? Let's see. It consists of 1 alpha hydrogens. So yes, you would get water once again. Along with this, you would get a nitro form. Same like you got in the primary nitroalkane. But as this does not have a primary hydrogen or does not have an alpha hydrogen, it would not undergo a process called as tautomerism. And yes, now we are remaining with only a blue solution. This was about secondary. Let's talk about tertiary now. If you react tertiary nitroalkane with HNO2, what would happen? Let's see. As this tertiary nitroalkane does not consist of any alpha hydrogen, no reaction would occur. So now students, if we understand the entire concept, let's see what happens. Then we said primary nitroalkane reacts, gives a blue solution, which on treatment with NaOH gives a red solution. We said secondary reacts, gives only a blue solution, and tertiary no reaction, so the solution remains colorless. Now what we can say is HNO2 reacts differently with primary, secondary and tertiary nitroalkane. So hence it can be used as an distinguishing test. And how does it react? Then it reacts like primary nitro compound on reaction with HNO2 gives a red color solution, secondary gives a blue color solution, and tertiary gives a colorless solution. So this was all for this module students. Meet you in the next module. Till then, thank you.